Hi, this is Sangram Redkar again, and I'm gonna talk about the second part of this lesson. We are going to talk about Symbolic Toolbox. And thank you for subscribing to my channel. Now there are quite a few subscribers. I'm glad to see that you are interested in viewing the material. Okay, so let me start with this. If I have a variable a is equal to 1, it simply assigns the value of a is equal to 1. Now, if I have another variable, just say t, it says it is an undefined function or variable t. So in the previous case over here, we assigned certain value to a. So as soon as Matlab encountered this a, it substituted that a for this value 1. However, Matlab at this point does not know what is this value t. So it's actually undefined. Now sometimes you have to do a symbolic manipulation, which means this t needs to remain as t. So t doesn't have to be equal to 1, 2, 3 or 4. So what we want to do is this t has to stay as t, and we should be able to find out what is the value of, say, cosine t, what is the value of integration or differentiation of, say, t square or t cube, and so on. So what we want to do is we want to create a symbolic variable, which means Matlab would treat this t not as a numeric value but a symbolic variable itself. So the way we start that is I say syms space t. So now what Matlab did, it created a symbolic variable t, and observe this a is equal to 1. Value of a is defined as 1, but value of t, Matlab simply states it is a 1 by 1 symbolic object. So what it means, it's perfectly fine if I were to say cosine of t. So Matlab got it. So it said it's a cosine function, and the argument or the variable that it's operating on is t. So what I could do is I could differentiate or integrate this particular function. Say for an example, as I go on, I just say here diff, that stands for differentiation, diff, and I say diff, I would say function. The function is cosine of t, and then what I want to do is I want Matlab to know how many derivatives am I looking at. Do I want to take just one derivative, or do I want to take two derivatives? So what is the order of differentiation? And then I need to specify the variable, and I'm gonna say 1. So what is the differentiation of cosine t? As we know, it's minus sine t. So let's see. Here we go. Matlab said the answer is minus sine t. Just for the practice, I'm gonna say diff of sine, again t in the bracket. T is the variable that we want to differentiate with, and I say 1, and it became cosine t. So Matlab actually does not know what the value of t, but it performed a symbolic manipulation, a symbolic operation on this function. So again, Matlab would allow us to use different mathematical operations. For an example, say integration. So for function, the integration function, we say int, and int again I would say cosine of t, and then again, as you can see, let me pull this window a little bit up here. As you can see, as soon as Matlab, I type in int, Matlab would give me a help. It would say, okay, how to use this function. This is the way this function can be used. Now, next thing is I could do a definite integral, or I could do an indefinite integral, which means I can specify the limits or I don't specify the limits. So what I would do is I would just say comma, I would say t, and then here it is, integration of cosine t, as we know it's sine t. Watch out here though, differentiation of cosine t is minus sine t, but integration of cosine t is sine t. Isn't that cool? Now what we can do is we can actually use some other functions, like we can use symbolic manipulation to find limits. So it would give us the value of the limit. So what is the limiting value? We can use symbolic operation to find out, I don't know, maybe what is the inverse Laplace transform. We can use the symbolic manipulation to find out, say, the Taylor series expansion. So let's see, let me try this. So what I'm going to say is I want to find out the Taylor series expansion. Taylor series expansion is an approximation of the function. So let's see, Taylor series, Taylor, I would say sine, and I want you to observe this. As soon as I type in Taylor, it gives me the help. So Taylor can be used multiple ways. So let's try this for a second. I'm gonna say Taylor sine t, and let's see what happens. Oh, here we got an approximate expression for Taylor series of sine t. Now just observe, as we know, sometimes we substitute sine t is equal to t. This approximation is perfectly fine for small values of t. As the values of t increase, we need to include these higher order terms. So this, what we see here, is the Taylor series expansion of this function sine t. You can try that again with a cosine function, say cosine of t, and then I say this is what is the cosine function. So observe, for small values of cosine, say if your cosine values are say 0 or 0.1, your approximation is gonna be equal to 1. So that's what it says. Say if your cosine value is 0, your value, the answer would be 1. If your cosine values are between plus and minus 20 degrees, then I guess you will have to include the different values of t. So your approximation would be the approximation I have highlighted over here. And as we go through this, there are some cool interesting applications. Like what you could do is you could have a function that is totally defined in terms of symbolic variable. Say let me say f is equal to, I'm gonna say t square, okay, plus t cube. Now as enter, Matlab without any complaint, it said f is equal to t square and t cube. I could actually integrate this function, I could differentiate this function, and if I want to, I can use this function multiple ways. And but say here is the case. What I want to do is I want to find out a particular value of t. Say say for an example, I want to find out what is the value of f when the value of t is say 3. And for that I would have to use the substitution. So what I need to do is I need to evaluate value of t, evaluate value of f when I supply the value of t. And we would talk about this more in the class, but symbolic calculation is very useful. It can be used in multiple ways, and you can do lot of manipulation and perform mathematical operations with a Matlab symbolic object. Thank you.
If you have never used Matlab before, this demonstration will get you started and show you where to go next to learn more. The Matlab language lets you construct commands to create and process variables. You can create variables by entering them into the command window here. For example, a equals 1, b equals 2, c equals a plus b, or d equals cosine of a. Matlab is an array-based language where variables can be vectors, matrices, or n-dimensional arrays. You can use square brackets to construct arrays. To create a row vector, you can type t equals 1, 2, 3, 4, 5. You can use the colon operator to simplify the creation of equally spaced arrays. T equals 1 to 5. You can recall previously entered commands by pressing the up arrow key. You can edit them, such as making t go from 0 to 1 in steps of 0.01. Adding a semicolon avoids command output being echoed to the command window. To find out what variables you have created so far, use whos. Or view a list in the workspace browser here. To see the value of a variable, just type its name, such as b. You can carry out operations on vectors just like simple scalars. For example, y equals sine of 2 times pi times t. This makes use of the constant pi predefined in Matlab. You can plot with plot t, y. In Matlab, variables can be complex, with I used to denote the imaginary part, such as x equals 3 plus 4i. You can enter matrices using the semicolon in the following way. A equals 1, 2, 3, 4, 5, 6, 7, 8, 10. Or you can use functions. You can browse a list of available functions in Matlab by clicking this icon, and then by browsing available functions by category, such as mathematics, statistics and random numbers, and random number generation. Here, we'll generate a matrix of random data. Double-clicking enters the function name. Pausing after typing a parenthesis shows a list of possible arguments. Here, we'll specify 5 rows and 5 columns. You can access help on all of Matlab by clicking the question mark here and either browsing for information or by searching. You can access demonstrations and the Getting Started documentation from the message bar here. You can find the size of a matrix by using the size command, which is also shown in the Workspace browser here. You can perform matrix operations such as B equals the transpose of A, or C equals A times B, which performs matrix multiplication, or C equals A dot times B, which performs element-wise multiplication, where the corresponding elements of each matrix are multiplied. You could calculate the inverse of A and multiply it times A to confirm that you get the identity matrix. You can select elements or sections of an array by indexing. For the variable A, here is the value at the second row, third column. Or, for the variable data, here is the section, rows 1 through 3, columns 2 to the end. You can set values in this way too. For example, with data, you could set rows 1 through 2, all columns equal to 0. The colon operator used on its own in indexing specifies all elements, in this case all columns. Note that the array indexing in Matlab begins at 1. You can plot matrices as well. If you wanted to display the matrix W, generated by multiplying the transpose of the sine wave vector y with itself, you could type surf of W, which creates a surface plot. That concludes the demonstration.